Let's do another proof. We're going to determine whether lines are parallel, and we have two sets of lines. Now, we're told that R and S are parallel, and there's my symbols, and we're told that angle 1 and angle 3 are congruent, but they're not on the same transversal. So this is what I have to work with, and I want to prove P and Q are parallel with the information that I have. Well, the first thing I want to do is just discuss that, hey, R is parallel to S, and the reason I can say that, it is given. Okay, so now that I've said that, I'm going to think about covering up this P so there's not so many lines to look at, and I'm looking at the 1 and 2 that I have here. They're in the top right side of the same place of R and S, the parallel lines, so they're corresponding. So now, since they're corresponding, I can state that they are congruent. So angle 1 is congruent to angle 2 because corresponding angles are congruent. All right, now I've said that, let's go ahead and talk about this. Angle 1 is congruent to angle 3, which is another given piece of information. I can say that. Now, when you look at these two together, angle 1 is congruent to 2 and angle 1 is congruent to 3. Do you see how angle 1 is in both places? You can mark those out and state that, hey, 2 is congruent to 3. Remember the transitive property we've talked about several times? So 2 and 3 are congruent by the transitive property of congruence. Transitive property of congruence. Now that I've said that 2 and 3 are congruent, I'm going to cover this up so I can't see that. Those 2 and 3, their positions are alternate interior. So the alternate interior, since I know that they're congruent, I can use the converse of that to say, hey, P and Q are parallel. And that's what I want to say. So P is parallel to Q, and that is the alternate interior angles converse. And that's what they asked us to prove, and we did.